Okay, so this is part two feeders and branch circuits. So this is where I'm going to size the conductor and overcurrent protection for a dryer. Okay, so my dryer's nameplate information is a 5,000 kilowatt or 5 kilowatt, 5,000 watt dryer, 120 to 40 volts. So it's an indicator of an Edison 3-wire, which indicates that it has two hots and a neutral. So when I use my, when I get my wattage, I would divide it by 240 volts because of that. Single phase NMD 90. Okay, so important. In a dryer circuit, you do not derate. Okay, so we do not allow for a derate. It's going to be its full wattage allocation. Okay, so the 5,000 watts that's on the nameplate is the 5,000 watts that we will use to find the ampacity for the load. So again, we have two hots, so we're going to have to use the 240 volt for your divider, and that gives me a calculated of 20.83 amps. Okay, so now I take that 20.83 amps and I go to table 2 to size the conductor. It's NMD 90, so I know it's copper and it's in a cable. So we go to table 2 and we need to go and utilize termination temperature to dictate the wire size. So in this specific example, we were not given termination temperature. So we need to use rule 4-006, I believe sub rule 4. Nope, sub rule 2. Okay, so no termination temperature. So we go to this rule. So the NMD 90 is just the insulation capacity of our wire. Termination temperature is what dictates which column we use in table 2. So 4-006 sub rule 2 states, so for the purpose of sub rule 1 and except as provided by other rules of this code, where the maximum conductor termination temperature for equipment is not marked, the maximum conductor termination temperature shall be considered to be A, 60 degrees Celsius for equipment rated not more than 100 amps, or marked for use with number 1 or smaller. So this here is 20.83 amps, definitely less than 100. Okay, and I just want to kind of read item B to you. We would use the 75 degrees Celsius column for equipment rated more than 100 amps, or marked for use with conductors larger than a number 1. So certainly less than 100 amps and a wire size less than 1. So we are going to use the 60 degrees Celsius termination temperature based on this. Okay, so now we can go to table 2. Should have table 2 memorized, honestly, but I don't. And I don't have it tabbed. Okay, table 2, 60 degree column. We have an ampacity of 20.83, which puts us into the 30 amps, which is a number 10. So I just want to take a minute to just give some notice to this squiggly symbol after the number 10. Okay, that is if you were to size the conductor for an unknown load. Okay, like when do you utilize, because that symbol is telling us you have to use 14-104. Okay, that is if you are sizing a conductor for an unknown load. So that could be your convenience receptacles in a residential application. That could be lighting loads, right? Unknown loads. This is a specific load that incorporates a motor. So we take table 2 at face value. Okay, we do not need to go to the 14-104, even though if we did, our ampacity is fine because it isn't greater than 30 amps anyway. That's a big factor in second period. When you have a load that's specific and known, we're not having to use that symbol because that's for unknown loads, okay, specifically. Okay, so we've got a number 10, and that number 10 is good for 30 amps. Okay, so next we would go to table 13 to size our overcurrent protection. And that would put us on a 2-pole, and it's going to be 2-pole because it's 2 hots, 2-pole 30 amp breaker. Okay. And for those of you that have done Resi, that's accurate, right? So you are using number 10 wire and you are putting it on a 2-pole 30 amp breaker. Okay, I have one more example I wanted to go over with you guys, and it was specific to space heat. Okay. So that 4-006, very important. Termination temperature dictates the column of the table that we use. If it is not given, you must go to 4-006. All right, so I have a 5.2 kilowatt space heat load. Okay, 240 volt. So it's incorporating 2 hots, no neutral, which is typical for a space heater. Okay, 75 degrees Celsius termination temperature, TT. Okay, so size the conductor and overcurrent device. Okay, so there's a couple of rules that I want to bring to your attention. So the first one being 62-110 item 1B. Okay, so we'll have a look at that specifically. I'm gonna tab off that table 2. So if we go to 62-110, it states branch circuit conductors used for the supply of energy to heating devices shall be used solely for heating device sets. Okay, so that's saying they're independent circuits, right? We're not tying anything else onto those circuits. And item B states have an ampacity not less than that of the connected load supplied. Okay, so that's A, independent, and B, saying it should not be less than that it's connected in. Okay, and the next rule I want you to look at is 62-114, sub rules 7 and 8. Service feeder or branch conductors supplying only fixed resistance heating loads shall be permitted to have an ampacity less than the rating or setting of the circuit overcurrent protection, provided that their ampacity is not less than the load, which makes sense. And item B states at least 80% of the rating or setting of the circuit overcurrent protection. So we have to make sure that our calculated ampacity is not in excess of 80% of that breaker. Okay, so that's what that's stating. And then it says in subrule 8, notwithstanding subrule 7B, where 125% of the allowable ampacity of the conductor does not correspond to a standard rating of the overcurrent device, the next higher standard rating shall be permitted. So it's super important that you're not going in excess of 80% of your breaker. And they're saying if that specific breaker isn't available, you can go to the next size up, only specifically for independent space heating loads. Okay. Sometimes you don't have the availability for a specific size breaker, so you're capable to go to the next size up based on that rule. Okay, so 5,200 watts. Okay, divide that by 240 volts, and that gives me an ampacity of 21.67 amps. Okay. I didn't tell you anything about the wire, so if there's no information given about the type of conductor used, we default to copper and in a raceway or cable, so we are going to table 2. Okay, and termination temperature is 75 degrees Celsius, so we're going to go to the 75 degree column, 21.67. That is putting us on a number 12. So I know the number 12 has that squiggly line next to it, but again, this is an independent known load, so we don't have to worry about going to 14.104. We can use table 2 at face value, and it states that a number 12 from the 75 degree column is good for 25 amps. Okay, so again, we size our conductor to the ampacity that's calculated, and then we get the amount of current that we're allowed to safely put on that wire, and that's the number we use to size our overcurrent protection. Again, table 13 for overcurrent. All right, and we're going with the 25 amps. Okay, so 25 would put me at a 25 amp breaker, it's saying. 25 amp breaker. Now, if we get 80%, if we want to figure out is 21.67 in excess of 25, well, based on that rule, we can't use that 25 amp breaker, right? So we would go 21.67 amps, divide that by 0.80, and that is 27.083, right? So we can't use that 25 amps because we are calculated as an excess or greater than an 80% capacity. So we have to go to the next breaker size up, which is 30 amps, okay? So we cannot use that based on sub-rule 7, right? So the next thing would be 30 amp breaker. Okay, so hopefully these two videos help you with the sizing of your conductors and overcurrent protection devices.